All right, good morning, college algebra scholars. We're going to continue on expanding a little bit on the factor theorem and the the factor theorem and the fact that if something is a zero, then when you divide using synthetic division, you should get a zero remainder. Okay, so this is just review from E2. Gave you problems like, given that 5 is 0, find the other zeros. Now, if 5 is a 0, what you also know is from the factor theorem is you know that x minus 5 is a factor. So if you know that 5 is a 0, that means that x minus 5 is a factor, because if you set x minus 5 equal to 0, you'll get 5. All right, now in order to find the other zeros, first thing we're going to do with f of x is we're going to do synthetic division with the 0 that you were given. So we were given 5. And the coefficients of the polynomial that we're trying to divide are 1, -5, -2, and 10. So to do synthetic division, if you recall, you're going to bring down the 1. Then you're going to take this 1 and multiply it by the 5, the 0 you were given. Put the result here. Then we're going to add -5 and 5 to get 0. And then we're going to again multiply the 0 by the 5, the red 5, and put the result here. So 0 times 5 is 0. Then we're going to add -2 and 0 to get -2. And then we're going to multiply again the -2 by the red 5 to give us -10. And then we're going to add again. And no surprise here, since we knew that 5 was a 0, we know that if we divide by the 0, that we should get a 0 remainder. If we don't, we did the synthetics division incorrectly. Okay, so we already kind of knew this, but what the result of the synthetic division does is it gives us the depressed equation. So the depressed equation in this case, since we started out with a cubic, we're going to go 1 down from a cubic, which would be square. So this would be 1x squared plus 0x minus 2. So we can simplify that to just say x squared minus 2. Now the fact that 5 is a 0 makes x minus 5 a factor. So we know that the factorization of this so far is x minus 5 times x squared minus 2. And we know that one of the zeros is 5 because we were given it. I'll move my paper down a little bit. So we know that we set each factor equal to 0 and solve. Well, if we set this factor equal to 0, we already know that one of the zeros is going to be 5 because they gave it to us. If we set this other factor equal to 0 and solve, we can use the square root method. And one of the clues that you could use the square root method here is that there are 2 terms, but they're not perfect squares, right? Not both of them. So we're going to add 2 to both sides. To get x squared is equal to positive 2. Then we're just going to take the square root of both sides. Remember, you always have to take the plus or minus. So you would get x is equal to plus or minus the square root of 2. We can't take anything out of under the radical. We'll do more of that radical stuff in our next unit, but we know that there's no perfect square factor of 2. So the solutions then would be of course, we know that 5 is one of the solutions because they gave us one of the zeros in the beginning of the problem. And the other two solutions would be what we got by setting x squared minus 2 equal to 0 and solving. All right, so that's review. That's the factor theorem that we had been studying before. So now the question I should ask you is, what happens if I ask you to solve a polynomial without giving you at least one of the zeros? Well, there is something that you can do. So when you're solving a polynomial, when you're not given a zero, there's a way that you can figure out possible zeros. So this number is going to be what they call your P, and this number is going to be what they call your Q. So if you list the factors of P, right, what numbers can multiply to give you 3, it would be 1 and 3, -1 and 3, +1 and -3, right? Those are all the things that can give you 3 or a -3. And you always want to find the plus or minus factors of those. So then what you do is you take all the possibilities and you put them at the top and the bottom and see what they simplify to. So let me show you how they're getting this right here. All right, so if we take, you could have, this is a P, 3 over 6, right? So there's your P and your Q. So factors of 3 are always plus or minus 1 and 3. Factors of 6 there's a few more, right? You could have always plus or minus. You could have 1 times 6, you could have 2 times 3, and you could have, again, 1 times 6. So then what you do is you simplify all the possibilities if you take P over Q and write a fraction for it, right? So you could have 1 over 1, you could have 1 over 2, you could have 1 over 3, and you could have 1 over 6. Then you could have 3 over 1, 3 over 2, 3 over 3, and 3 over 6. Now some of these numbers simplify to be the same number, right? Like 1 over 1 is 1, 1/2, 1/3, 1/6, 3, that's a separate number, 3 over 2. 3 over 3 is the same thing as 1 over 1, right? So we don't need to list that again. And also 3 over 6 is the same thing as 1/2. So we've already got that listed. So your total lists are the possible zeros that you could try would be the set of those numbers, both plus and minus. So let me grab these. Well, we might as well take the whole thing. Oops, let's try this again. Oops, I don't think I meant to do that. I'm trying to get it. That's not working. Well, it's sort of working, but let's see if we can get rid of that. All right, well, let's just duplicate the list that we got here. We got plus or minus 1, 1/2, 1/3, 3, 1/6. I think we missed 1/6, 3 and 3/2. All right, I'll just get rid of this. Okay. So it says now that you know 1, 0, you're going to find the depressed equation and solve for 0. So first thing that you need to know, wait, let's go back here. I guess I need to draw this here again. All right. So these are the possible zeros that we found right here. Oops. So now what we need to do is we're going to use a theorem that says if f of c is equal to 0, then c is a 0. Remember, we're just trying to find 0 here. Let's try each of these numbers in the original equation. So 6x cubed plus 8x squared minus 7x minus 3. So we're just going to put one of these numbers. One of the numbers that I always try first are the numbers that are whole numbers before I would try a fraction, just because sometimes it's just easier. So we're trying positive 1. Then we're going to try something else. Oh, and by the way, when you do this, this is not equal to 0, right? So 1 is not a 0. All right, so then we'll try other numbers. And it doesn't really matter the order you try, but just keep track so you know. Let's see, what should we try next? Let's try 3. And I'm just doing random numbers here. If you calculate that, that is also not equal to 0. Okay, so 3 isn't a 0. So you just keep trying numbers until you got one that when you put it into the original equation, you got a 0. So this may take a while. So let's see, let's try, I don't know, -3. And if you calculate that out, you can also see that that is also not equal to 0. And you would continue on checking. I'm going to skip ahead a little bit. And it turns out that -1/3 is a 0, because when you put it in the original equation, does in fact equal 0. This would be negative 1/3. You can use your calculator to calculate this. And I would suggest that you do, just especially if you're dealing with negatives. So it turns out that negative 1/3 is a 0. All right, so now that we have our 0 that will work, we're going to do synthetic division and find the depressed equation with it. So I'm going to take negative 1/3 and do synthetic division with the original equation. The original equation, I'll just write it up here, was 6x cubed plus 8x squared minus 7x minus 3. Okay, so we're just going to take those coefficients, 6, 8, negative 7, and negative 3, and do some synthetic division with it. So we bring down the 6 and multiply it by negative 1/3. Well, 6 times negative 1/3 is negative 2. So don't be afraid of fractions. You can always use your calculator for them. So 8 minus 2, or 8 plus negative 2, is 6. And we take 6 times negative 1/3 again, you get negative 2. Negative 7 and negative 2 is negative 9. And negative 9 times negative 1/3 would be negative 9/3, which is just positive 3. And we knew that negative 1/3 was a 0 because we used the rational root theorem. So we're expecting to get a 0. So now the depressed equation would be 6. And remember, we started out with a 3, so we're going to bring it down 1 power. So we got 6x squared plus 6. Now we're bringing it down 1 more power, x minus 9. Now we're going to take that depressed equation and solve it for 0. Well, like we've learned before, the first thing you always do is look for a GCF. So the GCF here would be 3. So I'm just factoring the GCF of 3 out. And then my next step would be to see if that 3x squared plus 2x minus 3 is factorable by using slip and slide method. It is not factorable. So you have two choices. You could either use completing the square method or the quadratic formula. So I'm going to use the quadratic formula, which says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So you just plug that in. Our b value is 2 in this case. Our a value is 3, and our c value is negative 3. So then 2a, 2 times our a value is 3. And then you just simplify from there. So we'd end up getting negative 2 plus or minus the square root of 28. Oops, made a mistake. This should have been a 2 because 3 times 2 is 6. So that means our a is a 2. So let's change that. So 2 times 2 is 4. So you get that. And then you just want to, you would just want to reduce that fraction a little bit further. So negative 2/4, same thing as negative 1/2. You could simplify that radical square root of 28 as the square root of 4 times the square root of 7. So then you would have 2 root 7 over 4, which of course you can simplify even further. Since 2 and 4 make 1/2, you have root 7 over 2. So let's see. We know that one of the solution was negative 1/3 because we got it using P over Q. And the other two solutions would be negative 1/2 plus or minus root 7 over 2. So that's exciting. We just solved a polynomial without giving any hints at all. They didn't give us any zeros at all. All right, let's do another one. All right, so we want, first step, we're going to do plus or minus P over Q. So our P value is negative, well, let's ignore the negatives because we already got that covered with plus or minus, is 11. And the Q value is 1. So here's P and here's Q. Make that more legible for you. All right, so we've got 11 over 1. Well, first of all, factors of P would be 1, just 1, right? The factors of Q would be 1 and 11. So the combinations you can get by making different fractions from the numerator and the denominator is 1 over 1, which is 1. You could have 1 over 11. Oh, wait, I got the P's and the Q's mixed up. Shoot. Let's try this again. Sorry. The P value is 11. Just mixed them up on the top and the bottom. So P value is 11 and the Q value is 1. So factors of 11 are 1 and 11. And factors of 1 are just 1. So the possibilities are 1 over 1 or 11 over 1. So total possibilities would be 1, always plus or minus 1, or 11. All right, and it's going to be plus or minus 1 and plus or minus 11. So let's try a couple numbers. If we did f of 1, we'd get 1 cubed minus 13 times 1 squared plus 23 times 1 minus 11. If you calculated all that out, this would not equal 0. So we can say that positive 1 is not a 0. Let's try negative 1. Turns out that's also not equal to 0. All right, so let's try positive and negative 11. Let's see, we put that all in our calculator and yay, we finally found a 0. Okay, so we know that 11 is a 0. So we're just going to use that 11 in our synthetic division with this polynomial using the coefficients of the original equation f of x. I'm going to do synthetic division, bring the 1 down, multiply it by the red 11, put your result there. Okay, you get -2. -2 times 11 is -22. Add those two together, you get 1. 1 times 11 is 11. And no surprise that the remainder is 0, right? Because the theorem above that said that if you put the 11 in the original equation, you get a 0 out. That means that when you divide it, you would also get a 0 remainder. So that gives us our depressed equation. So we started out with x cubed up here. So this 1 is going to be 1x squared minus 2x plus 1. And we're going to solve that equation for 0 in order to get the other solutions. So let's see, factors of 1 that add up to 2 would be 1 and 1. And they have to add up to a -2, so that means they both have to be negative. Therefore, you can factor this like x minus 1 times x minus 1. Now we set each factor equal to 0 and solve. And you'll get x is equal to 1 in both cases, which means this is what we call a double root since it occurs twice. So you don't list double roots when you're listing your final answer. You're not going to list it. So the solutions, or zeros, whatever you want to call it, are x is equal to 11. We know that from doing P over Q. And the other one would be 1. And you could even write double root. So there's your solutions. All right, let's try another one. All right, so we've got to figure out first what our P and our Q is. There's the coefficient and here. So here, -2 is your P, +1 is your Q. Wait, I need to go back here 1 second. I think I must have made a mistake right here because we came up with solutions of +1 here. So that means that this should have produced 0. So it probably does, and I just missed it. So let's just get rid of this and pretend that we didn't try +1 because we know that that's an answer. So it should have equaled 0. Okay, so we've got P over Q. So plus or minus P over Q. So P is -2, or we're just going to ignore the signs 2, and the Q value is 1. So factors of 2 are 1 and 2, and factors of 1 are just 1. So your possibilities would be 1 over 1, which is just 1, or 2 over 1, which is just 2. And of course, it's going to be plus or minus 1 and plus or minus 2. Okay, so let's try a couple. Let's see. Let's try f of 1. If you put 1 in the original equation, you'll get 1 cubed plus 1 squared minus 2. So that's 1 plus 1 is 2 minus 2. That does give you 0. Well, that's kind of cool. Okay, so if we do the synthetic division with that 1 that we know is 0, because when you put it into the original equation, it gave you 0. So let's see, we have to be careful here because there's missing powers. Okay, so the coefficient of x cubed is 1, coefficient of x squared is also 1. We're missing an x to the first power. So we've got to put a 0 in for that. And the other constant is -2. All right, so now we're going to do synthetic division. And we knew that 1 was a 0, so it's no surprise that our remainder is 0. What that does give us, though, is a depressed equation. So that depressed equation is x, let's see, we started out with cubed, so this would be x squared plus 2, move down 1 power x plus 2 equals 0. Well, factors of 2 that add up to 2, this is not factorable. So what we could do is use the quadratic formula. So we could say negative b, x equals negative b plus or minus the square root of b squared minus 4 times our a value is 1, c value is 2, all over 2 times a, which is 1. So you simplify all of that and you'd end up getting x is equal to -2 plus or minus the square root of, let's see, 4 minus 8 is -4. Put this over 2 and this over 2. So this would be -1 plus or minus the square root of -4 is 2i over 2. So you get -1. These cancel out. Plus or minus I. So your solutions are 1, oops, the 1 that we got using P over Q, and -1 plus or minus I that we got from doing the quadratic formula. All right, let's try one more. Let's see, we want a P and a Q. Here's our Q, here's our P. So plus or minus P over Q. P would be 10, Q would be 1. So the factors of 10 are 1, 2, and 5. And the factors of 1 are just 1. So if you combine those fractions, you'd get 1 over 1, which is 1, 2 over 1, which is 2, and 5 over 1, which is 5. Oh, and one other factor I forgot is 10. So those are the possible zeros. Let me move one to that I know is an answer just to save time here. So if I did f of, let's pick 5, just because I happen to know it is a zero, save a little time here. F of 5 would be 5 cubed minus 5 times 5 squared, just putting 5 in everywhere I see x, minus 2 times 5 plus 10. And if I calculate that out, I do get a 0. So I know that 5 is a 0. So I'm going to do synthetic division with 5 on the original equation. And I get, let's see, the coefficients are 1, -5, -2, and 10. So just doing synthetic division here. Right, then I find the depressed equation. Well, we started with cube. So this would be 1x squared plus 0x minus 2. I'm going to set it equal to 0 and solve. This is the same thing as x squared minus 2. So we can add 2 to both sides to get x squared equals 2. And we can take the square root of both sides. This looks very familiar. So we have x is equal to plus or minus the square root of 2. So our two solutions, or 3 I should say, are the 5 from the p over q and plus or minus root 2. All right, that should get you started. We might spend another day practicing some more problems like that. But see what you guys can do with the homework, and then we'll probably have an assessment on the next day. Have a good day, you guys.